recognized. Thank you, Jimena, and thank you to the organization of the University of Virginia, Michigan, and of course our own university. I'm very glad to be able to share this panel with you together with Jorge and Anayeli. Yeri, excuse me, we've been able to carry out different studies concerning these subject matters. Can you all see my screen? Thank you. This presentation that I will share with you is related to be able to reflect on the role of the architecture and landscape in the process of rehabilitation and integration of landscape in these operations, in these fragile, sensitive, and weak landscapes, which are related to lithium mining in salt pans, and also within other contexts of mining that are taking place in similar sites with similar value. Thus, the idea of my talk is to be able to present certain thoughts concerning the impact of lithium and how architecture and landscape architecture can contribute to establish this necessary intermediation and also anticipation, we might say, and thereafter also rehabilitation and reparation of these sites. This is a pilot experience that we have developed not only on territories or lithium mining territories, but rather territories that share a series of issues and characteristics that are linked amongst each other to these mining operations in the case of lithium mining operations. Now, this research and the development of the project that we shall be presented is enshrined within the research work in the Laboratory of Landscapes and Green Infrastructure within the Laboratory of the Catholic University, which is related to assessing the research problems concerning landscape architecture, especially related to planning and design of the landscape and the contemporary challenges in cities and territories and solutions based on nature, to adapt and for resilience purposes from a climate and disaster perspective, the valuation of ecological systems and cultures that convey an identity to the different territories. Now, the themes are divided into three lines of investigation based on the nature, green urban infrastructure, adaptation of climate change, the reduction of disaster, together with a project that we've worked with Jorge and Mr. Izaga that are here, Madam Arizaga that's here with us. And secondly, planning, conservation, and value of these cultural landscapes as a strategic resource. And of course, things that have to do with the impact of mining in those territories that precisely need to generate innovations to be able to sustain the local economies, and also rehabilitation and integration from a landscape perspective concerning these mining environments within a very valuable environmental landscape. And these are part of the characteristics that we can see on the screen, which are associated to these territories where mining activities take place, where, as we can see on the image, these small interventions have high incidence, especially from a visual perspective, but also from an ecological perspective, because these regions hold this, hence alterations generated by mining within these contexts are an important study field that from a landscape architecture we can handle so as to be able to guide these interventions with the purpose and the objective to be able to integrate these transformations of the territory with a planning and design in mind. From this perspective, this body, the saline body, which is found in the plateau, found in the lithium mining system in Chile, it is quite difficult. This is associated to the challenges for conservation purposes and to, of course, be able to face these mining challenges. And of course, we have had to research this in terms of this project as a pilot project, which is about to be developed within these contexts in the lithium mining system. And as we've been saying, not only at this symposium and previously, but also with regards to other activities that we've had with the University of Virginia. As a matter of fact, lithium mining, we might say that if we remove what we see in the image, it generates alterations from a landscape perspective that on the one hand side has an impact with water, the soil, vegetation, ecologically speaking, the quality of air, as mentioned before. But basically, this might be summarized in alterations in the aesthetic attributions, which of course have an impact in the quality of the landscape and compromises the values that we understand and have seen in their natural state. Nevertheless, the site operations that have these contexts also generates impacts with regards to a deficit in the planning concerning alternative usage, like, for example, usages related to tourism. And here we can see, thanks to the images on the screen, that there are alterations and impacts which are not necessarily assessed and studied, and therefore the need to rethink the way in which we generate these interventions in these contexts. Not only is it all related to mining activities, but also to other usage which are linked to the land. So the question is, what is the role of landscape architecture, which is our sphere in which we've focused our research to be able to mediate and coordinate the design of the modifications and changes in the landscape? This takes us back from a landscape tradition to the issues concerning interventions and operations in the different sites that might be connected with the work linked to different practices that from the perspective of the design, of course, these have been able to coordinate things with designs with a purpose beyond the work or the event or the intervention, because it also generates repercussions, which we might say establish additional values concerning those territories where these interventions take place, as we can see on this image, because of the work that took place by Robert Smithson in the spiral jetty. From that point of view, we might recognize three principles, and we can connect with Mr. Oskams and Mota's work to be able to understand the design as a tool to be able to empower these spontaneous works, and thereafter to produce actions that will follow authentic criteria. The second principle is related to designing, to visualizing processes where human beings might have access and experiment. In other words, to visualize stories which will have an influence and are related to these interactions amongst humans on that side, and the projects can contribute to social accessibility of these natural spaces or wilderness of those natural spaces that are being intervened with productive practices. And finally, the third principle addresses the design to provide new connections, new possibilities between existing processes through collaborations concerning these productive practices, practices that might be associated to conservation and other uses, as we realized or carried out annexed to tourism. So we definitely can see all these interesting cases. In other words, to establish these environments that might follow these principles. Taking into account what has been said concerning the interventions generated on these sites, we've recognized different strategies that have been divided into these 4 spheres, and they constitute a summary of a hypothesis. In other words, which might be these access points concerning the landscape discipline towards the planning of these sites. First of all, access and visualization, and we'll now give you a few examples applied to a pilot project that we are developing in another mining sphere related to other mining activities. And secondly, the buffering and connectivity specifically, and the singularity, mimesis, and own attributions of these sites, and the replacement and rehabilitation of the landscape components that have been altered. Now, these 4 strategies that we're are related to the components of the landscape that are submitted to these different alterations. Basically, 4 are related to soil and vegetation, which are considered as those components of the landscape that have a strong location conditions, which are recognizable under these perspectives that we can identify as landscape patterns. Secondly, water and air that contribute greater complexity in terms of management and assessment of the impact that is generated. And thirdly, in terms of usage, mining infrastructure, and on the other hand, usage, in this case, for tourist purposes, which might be associated to other possible usage that are established in that territory.
This can be found indigenous peoples, communities.
Ya debería de acabar esto.
The different components and the strategy we have been analyzing makes us understand that unifying the landscape planning and its design can be successful whenever there's a linkage and articulation with the strategies before mentioned and handling the different landscape components that are submitted to the potential impacts or effects due to mining activity. On the screen, you see a reference which is important to us, which has to do with the space of the activities in situ, which will give us the ability to mediate through design the different mining activities according to the ecological preservation objectives and compatibility with other potential activities. So I'll show you a pilot case. This is a case that it's not directly linked to lithium mining. It does share a common region, which is the Atacama Desert, and the coastal part has a issue regarding alteration in the landscape components that are similar to the ones we saw previously, related to a mining farm that has to do with a location nearby in that context. We're talking about the area at the center of continental Chile, which is the coastal part of the central Andes. There's still a transition way for climate between the desert aspect and the Mediterranean type weather, and it's a region that is characterized by a high level of vegetation, of endemic flora and fauna. There are some specific areas that are protected and that promote cultural values and protection values from these components. As we see on the screen, we see the territories in which mining activity has been developed, and we can understand in this broad aspect they are still focused on the valleys, but they are linked to the highlands as well, and up the way to the plains where we are developing the project. So by the valley of the Huasco River and where it comes out in the village, the city with the same name. This is where the mining project is located. That is also linked to the pellets area, which is a large industrial infrastructure that processes the material that is extracted from the region. And so the waste, the debris is the one that will be deposited here in this area, where you can see is a sort of valley, but has a huge impact in the vegetation and ecological fauna and flora, and also other impacts in other sectors such as touristic sectors or using the natural resources there. The project's objective is to develop a reintegration and refurbishing landscape through in mining background so that there can be more accessibility, and taking as a pilot case the area of the pellet Huasca location. So we understand landscape as a infrastructure to the social restructuring, and we also take phytotechnology, so structure-based solutions and vegetation system solutions so that we can solve these landscape issues. So this is where the project is located, and the main infrastructures, the productive infrastructures. From this point of view, there isn't only an impact in the direct area where the debris is deposited, but other lineal infrastructures as well. For example, mobility, transportation, storage, water management, and of course, transporting the material from one zone to another. So all of this causes a lot of alteration and of course impacts that could be divided in two main categories: visual intrusion, that was also present in the previous cases with the salt flats lithium mining, and the biophysical and aesthetic byproducts that are emanated from the production and the different operational stages. I won't go into detail within this table, but we see the different characteristics that are established in these impacts, not only in the area of the debris, but all the other infrastructures that are part of this huge mining system, and of course are linked to intrusion and alteration impacts to the landscape. Another objective of the project is to develop an intervention method that will allow us to interconnect in an organized way the different mitigation ecological processes through different interventions that will allow us to establish a space ordinance within the mining activities and other supplementary activities that are linked to work in favor of assessing accessibility and the rehabilitation of altered sites due to mining activities. From this perspective, the compensation and mitigation measures can be resumed in these 6 components: visibilization, mimetization, reposition, connection, buffering, and singularization. And all of these are interconnected to other activities that are called the master plan, with components and programs that can give us a better geographical space in the territory. We also went through the definitions of the landscapes and the different areas such as Park La Villette and other ones that are linked to the organization of landscape. This project is based on three basic components of the system that are linked to circulation, management areas, and equipment. These are strategic spots within the territory in order to activate specific practices for conservation and management of the components. Circulation will establish a system that will allow us to provide accessibility and will add up to the management of the different areas that are also linked to the territory. As for management areas, these are areas where the implementation is directly involved, where these technologies are implemented. So we have the renovation, reproduction, dissemination of the endemic species of that area, and finally, location of the equipment, which are the strategic spots that will be activated accordingly to the linear and zones matrix. So from this point of view, we have the areas of equipments that we have been establishing thanks to these activation programs in different areas, and that have been organized in 6 implementation stages. These are compatible with the implementation stages of the mining process of the Relave project. So we see a ongoing plan, a progressive plan, so that at the end of this period of time, which is 25 years, at the end we'll have all measures implemented and the landscape could also be better established with its rehabilitation steps. The model started to use this map of lines for the coastal area. And in this sense, it allows us to integrate different operations, the mining operations and other minings that have been adding on due to different infrastructures, such as mobility and touristic means, and other activities that have to do with managing and extracting resources in that region by the local communities. There are 3 priority sectors that have been established, 3 pilot sectors, 2 for viewpoints and another one for an interpretation center. This project allows us to establish and implement these strategies, especially for accessibility and visibility through the viewpoints and this sort of walkthrough or travel with pathways or nature trails that are connected, and we see different activities, and we can also disseminate information. We also have the buffering and connectivity strategy that are related to the linear strategies here at the border of the coast, a road that gives access to the mining activities and also has different characteristics. It has allowed us to have a public road and to connect other strategic points with other areas that have larger landscape value in order to use it. We are also able to see the different interventions of this road that are also linked to the phytotechnologies. We see other point of access that only allow vehicles, but also trails for people to walk. We have as well the singularization system in order to really identify the important point to start off. We also have the rehabilitation and reposition strategies or replacement strategies in which we will replace the endemic vegetation, and these are planted in greenhouses. These are also very important components that will allow us, on the one side, to generate ecological functionality and the replacement of the landscape components, but they also comply with the physical stabilization role of the relevant debris, which is also in this coastal area and which is threatened due to wind erosion and due to the work of vegetation and the soil replacement and other different materials can allow this physical replacement. So the replacement allows us to recompose the landscape components. That way, having a place that has better weather conditions and better landscape components that will allow for a better development of the soil and landscape. Taking into account that this area already had some impacts due to the close presence of other types of activities. These are some images of the pilot areas that have been developed. These are closely linked to the viewpoints. As I mentioned, there are some trails and hiking that can be done. We also want to implement replacement phytotechnology systems, as well as buffering and connectivity strategies for the landscape. So these are some of the components that also have to do with organization and the coordination of the different designs, starting by the planning, the design of the architectural landscape, by making this replacement possible with different development areas for other activities that will add value to the project site, as we see on the images.
Desde ese punto de vista también, la condición de reposición de la vegetación preexistente.
We also see that the vegetation replacement has led us to study different species that were found on site. We're able to do some studies and testing, especially for seeds that were collected. And in that way, we were able to create a parallel activity to the project site, which are the greenhouses. And the local community has been very interested by this. They are wanting to understand how this plant reproduction can be done, which is quite surprising and new in this area. So we're getting to know the endemic vegetation, and this also can be seen as a local development and innovation area for the local economy of the Baja City. And finally, this project has led us to a circular economy research field by studying all of the possibilities that could be established by using these materials, the tailings to construction materials that are found at the bottom of the salt flats. This is a material that has no heavy metals or any reactive materials. So in that way, we can understand alternatives to circular economy in order to reuse these components. So this is also part of a pilot stage we're working on in collaboration with the Laboratory of Range Construction Material of the Pontifical University Católica.
Osvaldo.
Thank you so much, Osvaldo.
Gracias.
Thank you for your fascinating presentation as well.